Assalamualaikum and hi, my name is Muhammad Iqwan bin Mazlan. My metric number is 2156663. And now, me and my groupmate Fazli and Amirul will present about the engineering application of thermodynamics in a radiator. So, what is radiator? A radiator is a device used to transfer heat from one medium to another, typically from a fluid, such as coolant or water, to the surrounding air. It is commonly used in systems where heat needs to be dissipated, such as in automotive engines, HVAC, industrial machinery, and power generation plants. So, how the radiator works? In simple terms, a radiator works like this. Imagine it is as a heat exchanger. Hot fluid from your car's engine or heating system flows through a tubes inside the radiator. As it travels, the heat from the fluid moves to the metal fins attached to the tubes. Air passes over these fins, cooling them down and carrying away the heat. This cool fluid then cycles back to the engine or heat source, ready to repeat this process. So, in a sense, a radiator helps keep things from getting too hot by transferring heat away in the air around it.
The first law of thermodynamics states that no energy can be created or destroyed in an isolated system. The energy can only change in its forms. In the context of a radiator, this law manifests in the heat exchange process. The heat energy received by the coolant from the engine is exactly equal to the heat energy lost by the engine. This principle is fundamental in determining the type of coolant needed to effectively manage the heat transfer process and maintain energy temperature within the optimal operating condition. The second law of thermodynamics states that in any natural thermodynamic process, the total entropy of a system and its surrounding will always increase. Applying this law to a radiator, we see that the heat flow from the hot engine to the radiator increases the entropy of the coolant. Similarly, as the coolant transfers heat to the cooler air, the overall entropy of the system will increase. This second law of thermodynamics will help us to identify the direction of the heat flow.
Hi and Assalamualaikum. My name is Muhammad Fazli bin Zulkarnain and my matrix number is 215791. So I will explain about the thermoanalysis of the radiator. The first aspect we can use is the thermal efficiency and the heat transfer. Basically, the thermal efficiency is a measure of how the well radiator transfer heat from the engine to the surrounding. Evaluate the design and performance of the radiator. We can maximize heat transfer efficiency. This involves considerations such as size and surface area, thermal conductivity material used, and the effectiveness of heat exchanger. Next, we can consider about the coolant flow rate and temperature difference. By optimizing the flow rate of coolant, we can enhance the convective heat transfer. Additionally, maintaining an appropriate temperature difference will ensure a continuous and efficiency heat exchange, prevent both insufficient cooling and overcooling. Next, we can consider is the design consideration. The material used for the radiator influence its thermal conductivity and overall efficiency. The thermodynamic analysis involves selecting material that can minimize heat losses and resist corrosion. Lastly, the irreversible and second law consideration. By analysis and minimize irreversible such as heat losses to the ambient environment to improve by improving the overall efficiency of the radiator. In addition, the increase in entropy due to heat transfer to the surrounding is also the inherent aspect. While it cannot be eliminated, the engineer work to mitigate its impact by design the radiator to minimize unnecessary heat losses. So to summarize, the thermodynamic of a radiator in an internal combustion engine play a critical role in maintaining operating condition. So the principle of the first and second law of thermodynamics guide the design and operation of the radiator that can influence the efficiency and the performance. So I think that's all from our group. Thank you.